Welcome back all of you to the channel CS Infosticks. So today's video is going to be a different video. So basically we will be learning about some AWS basic concepts. So I will be guiding you through whole the video, and I will be bringing such videos in the next videos also. So just stay tuned and let's start learning. So welcome everyone. So if you are just starting your cloud journey, and if you are feeling overwhelmed by the list of AWS, like Amazon Web Services. So you are in the right place. So today we are going to learn few things. Like we will be looking at core Lego blocks of AWS, such as compute, storage, databases, and networking. So let's start. And so as you can see in the first slide, so we are going to have a beginner friendly guide for the computing, cloud computing fundamentals, and uh, we will be building a complete cloud architecture step by step. So let's start the process. So as you can see, we'll be looking at renting IT instead of buying it. So before we talk about AWS, we need to understand what the cloud actually is. So as its core, cloud computing means renting computing power and storage like over the internet instead of buying it and maintaining it yourself. So as you can see, we don't need a physical infrastructure for us to maintain it. So we just rent it for using the computing power and storage also. So basically, think of like it's a spectrum of renting. So IaaS, that is infrastructure as a service. So basically, it is like renting the raw hardware. So next is PaaS, that is platform as a service. So it is like renting the environment to build things. So it is just like renting a fully equipped workshop, as you can see in the image. Uh, so likewise, PaaS works. So basically, PaaS gives you the tools to build without worrying about the underlying systems. So as you can see, the next one is SaaS, that is software as a service. So basically, it is used for using a finished product. It is just like renting a fully furnished apartment, example Netflix and Gmail. So SAS is just using a finished product, exactly like you can see Gmail and that. So without caring about the servers running them, you can use SaaS. So these were the cloud provider management. So let's move to the next slide. So basically, I wanted to ask like, why did everyone abandon their traditional data centers? When it comes down to flexibility and cost, in the past, if you wanted to launch an app, you just had to guess how many servers you needed. You also need to buy them upfront, wait for few weeks for the delivery. If your app went viral, your servers crashed. So basically, if it failed, you were stuck with expensive hardware. So the cloud solve this. You pay only for what you use, and you can scale it up or down in seconds. World move to the cloud. The first one is like traditional data center. So it has a very huge upfront cost, like heavy capital investment is needed. And as you can see in cloud computing, if you are using AWS or other clouds, so you can see it has a pay as you go. So you will be using the things which you are consuming, which are you are using them. Okay. So next is like speed. So for the traditional data center, it will be taking weeks and things to buy and install. And in terms of cloud computing, it is available in seconds. When it comes to scalability, you need to be keep guessing capacity limits. But in terms of cloud computing, you are scaling up and down instantly. So this happens. And last one is like maintenance. So in this, you keep managing the hardware, cooling, and power, because data centers are there. So for the data centers, you need to manage the hardware as well as its cooling, as well as the power, that is the electric consumption which is needed to run those data center, and the GPUs which might be running in that data center computers. And likewise in the cloud computing, as you can see, you need to only focus on your application only, nothing else. You just need to focus on your application. You don't need to know that what is going in the background, or what is my hardware doing, nothing like that. Let's move to the next slide. So Amazon Web Services, or AWS we can say, which was started in 2006, now the backbone of much of the internet. Even though it's the cloud, it exists physically on earth. Think of an AWS region like a major city. Inside the city, an availability zone is a specific secure building, And if one building loses the power, then the other building in the city stay online. So edge locations are like local delivery hubs, like a caching data close to the end users, so things load faster. So we can see that this is the foundation of AWS. AWS is basically the world's most comprehensive and broadly adopted cloud platform than any other cloud platforms we might be knowing. The other cloud platforms are like Google Cloud, Microsoft Azure, IBM Watson Cloud, and AWS, as you can see this. So today we are learning about AWS. So as you can see, regions. So geographic area where data centers like cluster are there. So this is just an example for now. You can see US East one, that is the United States. East one is the region name. So it is just the name they have given for that region, which is located in Virginia. Okay, and after that availability zones are there. So these are the distinct isolated groups of data center within a region. So within a region, so suppose Virginia is there, so in that region we will be able to get availability zones which are located and isolated groups of data centers within that region. So what is the edge locations? It is like mini data centers closer to the user for fast content delivery. So as you can see in the picture, AWS region in the city and the availability zones. So let's move to the next slide, that is renting a computer by the hour with Amazon EC2. So now we get to our first Lego block, that is compute. So Amazon EC2 is basically essentially renting a computer by the hour. So basically it stands for Elastic Compute Cloud, EC2. That is just like renting an apartment. You can choose a small studio if you just need to run a basic website, or massive penthouse. So if you're processing basically a massive amount of data, so you can pick the operating system, spin it up within minutes, and turn it off when you're done. So that's like the simple thing which you can do. So basically it provides secure, then resizable virtual servers. It all depends on you how much compute you require. According to you, you can scale it. So the specific amount of size you want, then CPU you can select. Likewise, you can proceed ahead. So as you can see, you can choose the CPU, memory, that is RAM, and operating system like Ubuntu, for example, or else Windows, etc. You can choose. Likewise, you have many options as you can see in the image also: Linux, Windows, Microsoft, Ubuntu. Likewise, you can choose any of the operating systems because this will be totally present on the cloud environment, that is the virtual environment. So you will need those things. You can do those things as this will be running in the cloud. So as you can see, instances type. So different server shapes optimized for different jobs. So you can choose the instances likewise. And as you can see, it is perfect for hosting websites, running enterprises apps, or crunching data. So let's move to the next slide. So this is like running code without managing servers using AWS Lambda. So while EC2 is like renting a computer, like that stays on until you turn it off, as we discussed in the previous slide. AWS Lambda is entirely different thing. So it is a serverless thing. You don't manage the server at all. You just upload your code. Think of Lambda like a vending machine. It sits quietly, consuming no power until someone pushes a button, as you might be knowing vending machines. So likewise, the machine wakes up, dispenses the snack, and goes back to sleep. You only pay for the exact milliseconds your code runs. So I think you might have understood the overall process of AWS Lambda. So it is a serverless compute services that runs on code only when it is triggered. Once you call it, once you trigger it, then it will start the process. So it does not need any provision or manage or continuously run servers. You can pay only for the exact compute time which you will consume. So it is a event driven architecture triggered by clicks, file uploads, or schedule. As you can see in the image, events are there. User uploads image, then the Lambda gets triggered. So Lambda runs resize code, and it gives a resized image saved in the output. So likewise, this is the process of AWS Lambda. Coming to the next slide, that is storing infinite files in Amazon S3. So this is like a second Lego block we can say, which is used for storage specially. So Amazon S3, you must have heard like Amazon S3 bucket. So it is basically used for storage things. So it stands for Simple Storage Services, that is S3. All right, and let's think of S3 as an infinite digital warehouse. So you can organize your files into it. It's like the boxes are called as buckets. Likewise, you can keep throwing files in there forever. Then you can keep it into forever. So likewise, it never runs out of space. It's incredibly durable. Amazon automatically copies your files across multiple facilities. So it basically makes it almost impossible to lose your data. So data can be lost from this. It is a very reliable thing. So it's perfect for media files and backups. So files are basically stored in those digital containers, which are called buckets, and you can see the durability, that is 99.99%. Data is virtually never lost. So you can be completely reliable on this bucket. It is specially used for storage, and it is ideal for images, videos, backups, and static website files. As you can see, the Amazon AWS, that is S3 console, it is just like a screenshot you can see. And let's move to the next thing, that is plugging a hardware into your cloud computer with Amazon EBS. So speaking of, if S3 is a warehouse for your files, Amazon EBS is the physical hard drive which you plug directly into your computer. Because EC2 instances are virtual, they need virtual hard drives to install their operating system and run faster applications. So basically, you attach an EBS volume to your EC2 instance, right? That is the great thing. If you like delete your EC2 instance, you can save the EBS volume and plug it into a new instance later. So as you can see, like EBS is Elastic Block Store. So as you can see in the image also, it is like direct low latency connection with EBS volume, that is the hardware, and it exists as a virtual hard drive actually. So basically, it is attached directly to an EC2 instance, and it has very fast low latency. Like it is a perfect thing for performance, which is required for operating system, that is OS, and the active databases. So this can be backed up easily using snapshots. So this was about Amazon EBS. Next one is like managing structured data with Amazon RDS. So this is the next thing, that is a third Lego block we can say, that is databases. Here comes the database. We had a look at the uh, Amazon EBS, that was a virtual hard drive. Then we look priorly with storage thing, that was the Amazon S3, and prior to that we had a look with Amazon EC2, that was Elastic Compute Cloud. So this is the next thing after that, that is the very important thing, especially the databases. So RDS stands for Relational Database Services. So basically, we can say like Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. Think of it as a relational database, like a highly organized, interlinked ledger or a complex Excel spreadsheet where every column relates to each other. So managing this traditionally is a nightmare of backups and software patches. So basically, RDS handles all the maintenance for you, letting you just focus on your data. So it automates time-consuming tasks like backups, patching, and scaling, and it supports familiar engines like MySQL, PostgreSQL, and Oracle. So it is perfect for structured data with strict relationships. For example, we can say financial records. So main thing is automated maintenance and backups for Amazon RDS. So next one is scaling infinitely with Amazon DynamoDB. So while RDS is a great for structured ledgers, sometimes you need something faster and more reliable. So enter Amazon DynamoDB. It is a NoSQL database instead of strict rows and columns. Think of it like a massive fast phone book, or else we can say dictionary. You look up a key and it instantly gives a value. It can handle millions of requests per second without even breaking a sweat, making it go to for high traffic mobile apps and games. So if you have a big game or apps or like that, so you can basically go for Amazon DynamoDB. So it is a very fast thing. It is a very flexible NoSQL database for any scale. It basically uses a key value model pair instead of strict tables and rows, and it delivers in single digit millisecond performance at any scale. So basically, it is ideal for applications like gaming, mobile apps, and IoT devices. As you can see above, it is the RDS SQL structured data, and in the DynamoDB, we can see NoSQL database. That is, it has a key value pair in that. So let's move to the next thing, like building a private network in the cloud with Amazon Web Services VPC. So our final Lego block is networking. It is a very essential part for AWS. When you put your resources in the cloud, you don't want them today to be exposed to everyone. So basically, AWS VPC allows you to build your own gated community in the cloud. Networking is very important thing, as you might be knowing. So you can create subnets which are like a private rooms in your house. Maybe you put your sensitive RDS database in the locked back room without internet access. So basically, the internet gateway is your front door, allowing your EC2 web services to talk to the public. So VPC stand for Virtual Private Cloud. So it lets you provision a logically isolated section of AWS, as we said, like subnets and internet gateways. So subnets are like private rooms within your network to group resources, and the front door, that is, it allows access to the outside web, is internet gateway. You can have basically you can basically have like full control over your virtual networking environment, just like you can see in the image Amazon VPC, the gated community. So like we can see the front end, that is front yard, which the other people can look at it, as you have given the access in public itself. So you can see that it is the public subnet, which is shown in green, and you can see below, that is private subnet, the locked room. No one can say that it's your private thing, that the private subnet you can store the things. So basically, you can see that the internet gateway, and then public subnet, and likewise private subnet. So this is overall virtual private cloud, you can see. So let's move to the next thing, that is controlling who gets into your cloud with AWS IAM. So IAM stand for identity and access management. So it manage the access to AWS services securely. So before we put everything together, we must talk about security. So security is very important. AWS IAM is the security guard of your AWS building. So by default, nobody is allowed in. You create users and you attach policy to them. A policy is a strict rule book for rule book. And for example, let's say a user name as John, who can view the S3 bucket, but he cannot delete them. So you can also use roles, which are like temporarily visitor badges. So they are like the even AWS services used to talk to each other securely. So you can decide what's the role for whom, and likewise you can give the role based access, that is identity and access management, who can access, who can delete, who cannot delete, likewise. So users are like individuals or applications needing access, and policies are like explicit rule books dictating exactly what a user can do or cannot do. So roles are like temporary hats that gives users or services specific permissions. So as you can see in the image, user, that is a someone is a user, and then policy, that is the rule book, like who is allowed and who is not allowed. Deny EC2, allow S3 view. So S3 view will be allowed, and if EC2 comes and then ask for the permission, then he won't get any permission. He will be denied directly. Okay, so let's move to the next, that is how all these AWS services work together. This is all the things in once, you can see. So this is like a aha moment, we can say. Let's snap our Lego block together. So a user wants to visit our website. You can see the user, as you can see in the image. So they enter through an internet gateway. Firstly, this is the whole overall step we can see for the Amazon Web Services. So the user comes in and he wants to visit our website. So the first thing, the barrier which comes is like internet gateway. So once you can see internet gateway is there, then a load balancer is present after that. It is like a traffic cop, traffic police, you can say, which sends them to an available EC2 server. So the next thing is like EC2 server, which is like a public subnet EC2 instance, which we learned, right? So then likewise we can see like the EC2 server will talk to our private RDS database. That's the next thing, that is the private RDS database. He goes to the RDS database for to lock them in securely. So it goes to log them, and it securely log them, and likewise Meanwhile, the heavy images on the website are loaded straight from the S3 bucket. So as we can see, the S3 bucket is here. All right. And likewise, the heavy images which are present in the website are directly loaded in the straight like S3 bucket to basically save EC2 processing power. And in the behind the scenes, we can say like IAM policies are making sure every services is only doing exactly what is allowed. So when user connects through the internet gateway, traffic is balanced across EC2 servers. Then likewise, the EC2 retrieves structured data from the AWS database. Static assets like images load directly from the S3 bucket. IAM silently governs all the permission in the background. So this is the overall overview we can see, and there is the IAM shield in the overview. So this is how the AWS services work together. There is the user, then comes the internet gateway, then load balancer goes to the public subnet first, and this all happens in the AWS VPS, right? And then lastly it goes to private subnet, and IAM shield take care of everything. So it basically governs all the permission in the background itself, and S3 is used for storage things. So let's move to the next slide. That is, here are the foundation in AWS. You know that compute services like EC2 and Lambda run on your code. So storage services like S3 and EBS hold your files. Databases like RDS and DynamoDB organizes your data, and VPC and IAM keep it all connected and secure. So the best way to learn from here is to log into AWS console, spin up your very first EC2 instance. The cloud is yours to build. So as you can see, compute has the EC2 and Lambda. So these are basically the engines powering your applications. Then we can see the storage, that is S3 and EBS. This is basically the warehouse and hard drives holding your files, and the databases like RDS and DynamoDB. So it is like organized ledger managing your data. And the last one, that is the very important one, that is networking and security, which comes with VPS and VPC and IAM. So this is like the walls and guards keeping it safe. So safety is very important for your data. So this is the very important thing, that which role you will be giving to which user or application, and guarding it with the networking, especially using VPC and IAM. So for database, you will use RDS, or else if you have very large files, then you can use DynamoDB. EC2 and Lambda will are the engines like compute powers of your AWS, and for storage we use S3, right, and EBS. So I hope you have understood the whole process. Like, we covered almost all the basic things which are required for the AWS core services. So we learned compute, database, storage, and networking. So I hope you have understood. We will be coming with more such videos in the upcoming time. So do let us know in the comment that how was the video and have you liked it. So make sure you subscribe the channel as well. And thank you so much for watching. Keep supporting CS Infosticks.